Camera objects can make all the difference between a dynamic and engaging animation and a pretty nice scene with not a lot going on. Camera objects can be used to zoom and to pan around in a 2D scene, or to simulate the feeling of 3 dimensions, using parallax motion by placing layers at different distances from the camera. Camera objects also come with a multitude of useful features, such as fog and focus blurring. In this video, we're going to look at how camera objects work and all of the neat things you can do with them. All Alight Motion projects are rendered from the point of view of a camera looking at the screen, just as you are looking at the screen right now as you watch this video. A camera object is a special kind of layer that lets you take control of the position of that camera, to show the layers in your project from a different point of view. By animating camera objects, you can create dynamic panning, zooming, rotation, and parallax motion, even when the camera is the only moving part in the project. And by using multiple cameras, you can easily cut between different points of view in a single scene. You've seen what can be done with a camera. Now we'll learn how. Let's go back to a previous version of the balloon scene, before we added the camera, and go through the process step by step. You can download the project to follow along. We'll start by adding a camera. Tap on the Add Layer button, go to the Object tab, and then tap on Camera. This will place a camera object on the timeline. The wireframe indicates the area of the composition that is visible to the camera. If we go to Move and Transform and move it around, only the wireframe moves. Not very interesting. What we need is to see things from the camera's point of view. We'll do that by turning on Active Camera View in the View Options panel. On an iPad, this is on the left side of the screen. On a phone, tap the View Options button to reveal the panel. Tap this button to switch on Active Camera View. Now, if we move the camera, we can see the entire scene appears to move, because we are looking at it from the camera's point of view. Notice that from our new perspective, some layers seem to be moving faster than others. This is called parallax, and happens because the layers are different distances from the camera. More on that later. In addition to moving the camera around in 2 dimensions, we can also move the camera forward and backward. It's important to understand the coordinate axes used in Alight Motion. The x-axis controls a layer's horizontal position, and the y-axis controls a layer's vertical position. These are the axes that are normally adjusted when you make swipe gestures in the control pad. There is also the z or z-axis, which represents the distance into the screen. Positive numbers are further away, and negative numbers are closer. To make the camera move forward or backward, we need to adjust its position on the z-axis. To do this, tap the Z coordinate indicator above the control pad to select it. The control pad is now adjusting the layer's Z position. Swipe up to move the camera forward, and swipe down to move it backwards. When adding position keyframes to animate a layer, it's important to remember that the X, Y, and Z coordinates are all animated as a set, and a position keyframe will affect all of them. If you want to animate the Z-axis separately, there is a way to do that, which we'll explain later in the video. To switch the control pad back to panning the camera in 2 dimensions, just tap on the XY coordinate indicator. Notice that when we move forward and backward on the Z-axis, the other layers move at different rates, and some even disappear behind the camera. This is because the layers in our project have been placed at different Z coordinates. This is also what causes the parallax effect we noticed earlier. To understand parallax better, imagine looking out the window of a moving train. closer objects appear to move further and faster, while those in the background move more slowly. While we're in Move and Transform, let's look at how rotation affects the camera. Like many other types of layers, camera objects can be rotated. When you adjust the rotation setting, layers seen through the camera appear to rotate in the opposite direction. Now try turning off Active Camera View. You can see that the composition area has not changed. Remember, it's the camera that's actually at a new position. We haven't changed the scene's size or any of its layers. Notice that the wireframe of the camera is smaller than before, indicating that the camera is closer to the composition and is therefore seeing a smaller piece of it. The size of the camera's wireframe in the preview indicates the area of the composition visible through the camera and comes from the camera's position along the Z-axis combined with the camera's view angle and zoom settings, which we'll explain shortly. Changing any of these will cause the apparent size of the camera wireframe to change. Speaking of the camera settings, it's time to learn more about them. If we navigate to the Camera Options panel, we can see there are 3 tabs that control the properties of the camera. This tab controls the view angle and zoom distance. This one controls focus blur, and this one controls fog. We'll start with view angle and zoom distance. The zoom distance determines how big or small layers seen by the camera appear. A composition-sized layer, placed exactly the zoom distance away, will perfectly fill the screen when seen from the camera. Similarly, the view angle determines the angular extent of the scene seen by the camera. If you think about it, these 2 things are directly connected. If you zoom in, you see less of the canvas, which is exactly the same as having a narrower view angle. If you zoom out, you see more of the canvas, a wider view angle. In other words, these settings are interdependent. When you change one, the other changes to match. Note that moving the camera forward or backward also makes things appear larger or smaller. But unlike changing the zoom or view angle, moving the camera forward also changes the perspective. One more thing. If you pinch in the preview to resize a camera or make scale adjustments in the Scale panel in Move and Transform, it is actually the camera's view angle that changes. Camera objects do not actually have a scale setting. OK, let's move on to focus blur. When you use a real camera, you'll often notice that some objects in your photo or video appear blurry because they are too close to the lens or too far away. Most cameras allow you to adjust the focus, controlling the distance at which objects appear crisp and clear. Cameras in Alight Motion don't have lenses, so everything in your scene will start crisp and in focus. But sometimes you want that blurriness. It can lend a sense of depth to your animation, or call attention to important parts of a scene. This is where focus blur comes in. Focus blur simulates the blur you see in real cameras by applying a Gaussian blur to each layer based on its distance from the camera. As we saw earlier, our project has several layers placed at different Z coordinates, and which are therefore at different distances from the camera. That makes it perfect for experimenting with focus blur. Let's start over by adding a new camera object to the timeline. We'll turn on Active Camera View to preview through the camera. If we take a quick look in Move and Transform, we can see that the camera's initial position along the Z-axis is a negative number. New cameras are automatically positioned to see the entire composition. You'll understand why this matters in just a moment. Now navigate to Camera Options and go to the Focus Blur tab. Notice that the default focus distance is the same as the Z coordinate we just saw, except that it's a positive number instead of a negative one. This balances out with the position of the camera. so that layers with a Z coordinate of 0 will be in focus. Turn on focus blur to see for yourself. You'll notice immediately that both the sky in the background and the grass in the foreground are significantly blurry. The red hot air balloon is moderately blurry, and the remaining layers are in focus. Take a look at the other layers to see why. You can see that the sky has a positive Z coordinate. The grass, on the other hand, has a negative Z coordinate. Why are the trees in focus? If we take a look, we can see that their Z coordinate is 0, which is where our camera is focused right now. Let's bring the red hot air balloon into focus. There are 3 ways we can do this. One way is to move the balloon closer to the camera. Tap the balloon layer, tap its Z coordinate, then swipe down until the Z coordinate reaches 0. It's in focus. Another way is to move the camera closer to the balloon. Take note of the layer's Z coordinate. This is how far we have to move the camera forward. Now select the camera layer, go to Move and Transform, select the Z axis, and swipe up to move the camera forward the appropriate amount. Once again, the balloon is in focus, but this time we've moved forward within the scene to do it. The last way is to adjust the camera's focus distance. Remember the layer's Z coordinate. This is how much we need to adjust the focus distance. Navigate to the Camera Options panel and switch to the Focus Blur tab. Increase the focus distance by the appropriate amount. Yet again, the balloon is in focus. Only this time, we didn't move either the camera or the layer. As you can see, focus distance is the distance from the camera at which layers in the scene appear sharp and in focus. But sometimes you want a little flexibility. This is where depth of field comes in. Depth of field defines the range on either side of the focus distance that objects appear in focus. Increase this to bring more layers into focus. Lastly, you can use blur strength to fine-tune the strength of the Gaussian blur applied to objects that are out of focus. As with any properties in Alight Motion, you can use keyframes to animate camera properties. This can be a powerful tool for storytelling. Here, for example, we've animated the focus distance to simulate a focus pull within our scene. Note that focus blur can be a very heavy effect to render and may impact preview performance, especially in projects with many out-of-focus layers. If you notice preview lag while working on such a project, try turning off focus blur while editing and turning it on again when you are ready to export. Now we come to the last feature among camera options, fog. Fog does exactly what it says, creating a hazy atmosphere that can obscure the layers within and behind it. Although you might think of fog as white, Alight Motion allows you to set it to any colour. For example, you might want a dark grey or black fog for heavy smoke, green for toxic gas, yellow or brown for smog, or whatever fits your scene. Fog is calculated based on a near distance and a far distance, which determine how much fog is applied based on the distance of a layer from the camera. Any layers closer than the near distance will be unaffected by fog and appear completely unobscured. Layers further away than the far distance will be invisible, entirely hidden by the fog. Layers in between will be partially obscured, depending on how far away they are. You can also add keyframes to animate any of these values. Note that if you move the camera forward or backwards, the amount of fog colour applied to each layer seen by the camera will change, because there is more or less atmosphere between the camera and the layer. Feel free to experiment with these positions to get exactly the foggy look you're going for. OK, now that we've covered all of the camera properties, let's talk a bit about how multiple cameras and camera visibility work. As with regular layers, you can tap on the visibility button to make a camera object invisible, or visible again. Invisible cameras have no effect on the project at all. Turning a camera's visibility off will give priority to other camera objects in the project, or, if there are no other cameras, to the default overview camera. Changes in the visibility of camera layers are reflected in the final result when you export a project. In contrast, the active camera view option is purely for reference and only changes what you see in the preview area, leaving the exported results unaffected. You can add as many camera objects to your project as you want, but only one camera will be active at a time. Whichever visible camera object is highest on the timeline will be the active camera for its duration, and whichever camera object is lowest on the timeline will act as the default camera whenever no other camera is active. Notice that even though the length of this camera layer is only 2 seconds, its influence extends for the entire duration of the project, as indicated by the red shading on the timeline. This means that whenever no other camera object is active, the bottommost camera will become the active camera. If you know you will be creating a project with multiple cameras, it is often helpful, when beginning the new project, to start by adding a camera object at the bottom of the timeline to act as the default camera. We're almost done. Let's cover how other Alight Motion features interact with camera objects. There are 2 important parts to this: effects and parenting. There are a few effects that are very useful with camera objects. Motion blur is one of them. Applying motion blur to a camera object gives the same results as if you had applied it to every layer in the project individually. This can be very handy if you want to turn motion blur off for better performance while editing, and on again for better quality when exporting. Motion effects and effects that modify the layer transform also work great with camera objects. For example, adding the auto shake effect to the camera, reducing the frequency and magnitude, and increasing the slack will resemble handheld camera shake. Or use oscillate to simulate a camera bobbing in water. Cameras with motion effects can simulate realism or be used to create more dynamic animation. So take some time to experiment. You'll be surprised by what you're able to achieve. The other feature that interacts with camera objects is layer parenting. Parenting layers to camera objects, or vice versa, can produce a variety of very useful results. For example, to make it look like something was filmed through a camcorder, just make a camcorder overlay and parent it to the camera so that it moves together with the camera object. You can also create a translucent layer that resembles the glass pane and parent it to a panning camera to simulate the view from a moving train. You may also find it useful to parent cameras to other layers. For example, to have a camera track a moving layer, just parent the camera to that layer. You can use this technique to animate the X, Y, and Z axes separately by animating some axes on the parent layer, leaving the camera free for independent keyframe animation on the remaining axes. If you don't actually need to see the parent layer, consider using a null object as the parent layer. Combining parenting and cameras can be a powerful tool for creating sophisticated animation, while reducing the manual labor needed to animate individual layers. Let your creativity run wild. We've covered a lot in this video, including how to add camera objects, enable active camera view, move cameras on the X, Y, and Z axes, adjust camera properties such as view angle, focus blur, and fog, and how cameras interact with other features in Alight Motion. You should have a good idea now of how cameras work, and the wide variety of techniques you can apply to leverage the power of camera objects in Alight Motion. So, dive right in and start making mind-blowing animations with dynamic cameras. Show us the brilliant ideas you come up with by using the hashtag #AMCamera. If you found this video useful and would like to be notified about future content, don't forget to subscribe and turn on the notification bell. If you have any other questions or feedback, please leave us a comment.